Welcome, dear students, to the third session of probability. I am Jivani, and today we will be exploring the concept of conditional probability. Well, this concept is very important to go ahead with the other exercises on law of total probability and Bayes theorem. So please understand this concept very carefully as it is very crucial for all students of CBSE, ISC and different curriculums. What do I mean by conditional probability? As the name says, an event will occur given that some conditional events have already taken place in the past. Example, suppose I say two teams are playing a cricket. Team A versus team B. Suppose team B is batting second. What is the probability that team B will win the match given that they have played the first 40 overs as per the required run rate and they have 7 wickets in hand? Understand, when we used to solve probability, we always focused on whether a person or a team will win or not. Here, I am saying team B will win given that it has already followed the run rate and it has 7 wickets in hand. That means it will win given a certain condition has taken place. Contrary to which, suppose I say again team A and B is playing the match. What is the probability that team A will win? Suppose I put up a condition that team A will win the match given that they have taken 5 wickets in the first 20 overs. That means their chances of winning gets higher based on the performance mid journey or based on what has already happened in the past. That is exactly what we are going to explore today with conditional probability. What I am saying is, what is the probability A will occur given B has already taken place? So, let me decode this in a very simple language as per the Venn diagram. So, if I have over here my sample space, my event A is over here, my event B is over here. What is in common between them is the intersection. I am saying what is the probability that A will take place? What is the probability A will take place given that B has already taken place? Now, students, the circle of B has already taken place. The only thing which is in your favor for A taking place, I repeat, the circle of B has already taken place. The only thing in your favor for A to take place is the intersection part. So, probability that A will occur given that B has already taken place. So, first, what was the chance of B taking place? After that B has taken place, what is the chance that A will occur along with B? So, in simple language, probability A given B, A will occur given that B has already taken place is A and B taking place upon the probability of B taking place. So hence my conditional probability of A given B is probability A intersection B upon B. Similarly, students, if I say probability B will occur given that A has already taken place, that means probability B given A. That means you are telling me A has already taken place. So what was the chance of that event A happening? That means what was the chance of the opposite team losing 5 wickets in the first 20 overs? So probability A. Now that they've lost 5 wickets, what is the chance that A and B both will happen? So my conditional probability of a given event based on what has already happened are these two formulas. But understand what happens midway. Now, when I am telling you A has taken place, given that B already taken place. If my question said probability A not taking place, given that B happened, do not by heart formulas. Understand. Can I follow the same pattern of the two terms being in intersection and the term in the given part being in the denominator? So can I call it as A complement and B upon probability B? If you recall, do I read this as B and not A? B and not A means B has taken place, but A has not taken place. Do we call it as only B? Only B was from the circle of B, remove A intersection B. That is your numerator. Well, your denominator was probability B. So can I divide this individually by probability B? Students, if you observe, is this actually 1 and is this your formula actually for A given B? That will be probability A given B. So what has happened over here? When event B has taken place, after that A will happen or A will not happen. When I'm finding A taking place, and in my other part of the question is A not taking place, we know total probability is 1. So 1 minus A happening will give you probability of A not taking place. Similarly, over here, if I ask you probability of B not taking place, given that A has taken place, we can directly write it as 1 minus probability B given A. So hence, my point of concern here is do not by heart formulas. If you by heart, you tend to forget and go wrong. Understand. Take a pause, go on the side, solve it for 10 seconds, come with the correct formula so that you don't lose marks in your exam. Now, if you understand, we have also done a concept where we said if A and B are mutually exclusive, if A and B are mutually exclusive, that means probability A intersection B is 0. In that case, your diagram is how? You have your circle for A, you have your circle for B. There is nothing common. So if A intersection B is 0, so when we ask you probability of A given B, will it be A and B 0 upon probability of B? 0 upon anything is 0. And similarly, probability B given A will also be 0 when it is mutually exclusive. But, pause. If I say A and B are independent, what are independent events over here? Suppose you've tossed a coin, you got a head. Now I am going to toss a coin. I can get either a head or a tail. My output does not depend on what you've done. That means this is an independent event. My answer is independent to what you have got. Students solving a sum is independent. People applying for a job, my interview is independent on how you have performed. So students solving a sum, people applying for interview, people running a race, these are all examples of independent event. In that situation, probability of A intersection B, we know, is probability A into probability B. Keeping that in mind, students, can I say probability A given B will be probability A intersection B upon probability B? But did we not say A intersection B is probability A into probability B, which will therefore get cancelled, and I'm left only with probability A. So, what is the event of A taking place given that B has already taken place, but A has nothing to do with B? So, A taking place, whether B has taken place or not, does not matter. Therefore, probability A given B is only A, and similarly, probability B given A will only be B. Please understand, we are putting a good amount of time to understand the concepts. If your concepts are sorted, you can solve any kind of sum coming on this type. So take a moment, look at the formulas carefully, understand them before we explore the sum. If you find the concept really helpful, I would request you to kindly subscribe to the channel to get more such videos. Let us now explore probability sums. Well, if I have to pick up a sum, this is the one which I would prefer. My question says A and B are two events such that probability of A is not 0. Find B given A if A is a subset of B. Let's look into the first part. My first part of the question says A is a subset of B. That means if this over here is my sample space, if this part over here is B, I am saying A is a part of B. Okay? Keeping this in mind, my question says find probability B given A. What is my formula for B given A? Probability A intersection B upon probability A. Now, look at the diagram, students. A intersection B. What is common in A and B? That is your entire set A. I repeat, sample space B, A is a part of B. So common in A and B is A. So probability A intersection B is A upon probability A. Well, the answer is 1. So this is a good sum to test your conceptual knowledge. Now, next part says A intersection B is a null set. Pause before I solve. A intersection B is a null set. When does this happen? This happens in mutually exclusive, which we just put up on the screen. So, when I am saying A intersection B is a null set, I know probability A intersection B will be 0, and hence probability of B given A, which is A intersection B upon A, is 0 upon any number which is defined to you as not taking 0. Your answer here is 0. So a good concept testing sum. Next, my question says I have the values for probability A, B and B given A. I have a conditional value given to me in the sum. My question is telling me to find A intersection B, A given B and A union B. Now wait, I know A, I know B. Always understand, when I want to find an unknown, some related data should be in the sum. Which for me is B given A? Do you know the formula for B given A? Probability B given A is A intersection B upon A. I know the formula for B given A in the sum as 0.4. I do not know A intersection B, but probability of A is 0.8. I multiply this over here. So probability of A intersection B is 0.4 into 0.8. Now, even good students make a very silly mistake here. When we come till here, we say, hush, I know the sum. And then we say 8 into 4 is 32, 3.2. No, two decimal places. And hence your answer is 0.32. Yes, you may have a calculator, you may opt for that. But I somehow believe that breaks your sync. So if you're comfortable with calculations, pause, go easy. So my first part is done. Now, when I already know my A intersection B value, my question says I want probability A given B. So, probability A given B, formula substitution is A intersection B upon probability B. I just found this value over here as 0.32. I know my probability of B is 0.5. For my understanding, I'm calling it as 0.50. Okay. So can I write this as 64 by 100? That is 0.64 if you want it in the decimal value, or if you want to go for your least fraction, can I write that as 32 by 50 is nothing else but 16 by 25. Why am I writing these options? Yes, when you put the value in your calculator, you can jump to the fraction. Please understand, when I say my sums have to be of higher order, well, this practically I can jump to asking you A given B. And this is a good concept testing question which you should be comfortable enough to jump to the answer. Now, I'm asking probability A union B. We've already done this. Probability A union B, basic formula is probability A plus probability B minus probability A intersection B. Now I have all the values. Probability A is 0.8, probability B is 0.5, and A intersection B we found over here as 0.32. That leaves me 5. 50 minus 32 is 18. That gives me over here 0.98. Pause. In place of asking A union B, had I asked extra, find A complement intersection B complement, can you say this is actually A union B complement using your De Morgan's law, which is 1 minus probability A union B, which you know over here is 0.02. Can you try to use this information? If you did not want to write all the formulas, put it up in a Venn diagram and verify whether your answers are coming right or not. Understand these sums, and then we move on to the next one. My question here says, this time I have given you union. In the previous sum, we had given you a conditional value. So I have probability A, probability B, and A union B. I am asking you probability A intersection B. Had I not put up that, probability A given B. For that, you have to find the intersection values. So, do I know the formula for A union B? Can I say probability A union B is probability A plus probability B minus probability A intersection B? I know this is 7 by 11. Probability A is 6 by 11. Probability B is 5 by 11. I do not know the value of A intersection B, which I throw on the left hand side. When this comes here, guys, minus will become plus. So this is probability A intersection B. 6 by 11 plus 5 by 11, you know, is 11 by 11, and minus 7 by 11. So I'm left over here with 4 by 11. Once I know my intersection part, can I go further to solve probability A given B? That is probability A intersection B upon probability B. I already know A intersection B is 4 by 11. Probability B is given to me in the sum is 5 by 11, and hence my answer is 4 by 5. Let us take a pause to now understand this conceptually. What is the chance A will happen given that B has already taken place? So whenever B takes place, 4 out of 5 times A will also take place. Whenever B will take place, 4 out of 5 times A will also take place. So when something has already taken place, when you want to predict that okay, the next part will happen or not, students, that practically is your conditional probability. Now let us explore the same sum in the form of a Venn diagram. So if I say this over here is my sample space, I am defining event A and event B over here, where the common part is A intersection B. Now, understand, probability of A is given to you as 6 by 11. Probability of B is given to you as 5 by 11. Yes, at a point we said 6 by 11 plus 5 by 11 adds to 1. So we may say it could have been exhaustive, but no. The data says A union B is 7 by 11. It is not adding to the full sample space. Why? Because when I added A and when I added B, it came to 1, but there was a double addition of A intersection B. So when I know my total probability over here for A union B was 7 by 11, that gave me the answer for A intersection B as 4 by 11. So, students, please understand, if A intersection B is 4 by 11, do I know probability of only A? Probability of only A is 2 by 11. And my probability of only B over here will be 5 minus 4, that is 1 by 11. So I can use those concepts also over here. My question says A will take place given that B has already taken place. I am saying the circle B has already occurred, which is 5 by 11. Okay. In that, my A will take place. That means only this intersection share, which was 4 by 11. And hence we had 4 by 11 upon 5 by 11. So if you decode the Venn diagram also, you can verify your answers. Let us explore another sum here. My question says 3 events A, B and C have probabilities given to me. Given that A intersection C probability, B intersection C, find the other probabilities. Again, understand why we are using direct data sums, but a new concept is coming in place. So I have probability of A is 2 by 5, probability of B is 1 by 3, probability of C is half. Further, I know probability A intersection C is 1 by 5. Probability B intersection C is 1 by 4. My question is telling me find probability C given B. Pause. I want probability C given B. That is probability C intersection B upon probability B. Yes, I have the data. That is 1 by 4 divide by 1 by 3. So that will become 1 by 4 into 3, and hence your answer is 3 by 4. Next, probability A complement intersection C complement. So probability A complement intersection C complement, De Morgan's law, is probability A union C the whole complement. That is 1 minus probability A union C. So 1 minus, be careful with the minus sign, probability A plus probability B minus probability A intersection C. I know probability A, I know probability B, I know A intersection C. So I have 1 minus probability of A is 2 by 5. Probability of B is 1 by 3. Sorry, probability of C is what will come over here. Probability of C is 1 by 2. And A intersection C, what I know over here, is 1 by 5. So, can I say 1 minus? If I want, can I match this LCM of 5 and 2 to 10? So, can I say this will be 4 by 10 plus 5 by 10 minus 2 by 10. So, 4 and 5 is 9, minus 2 is 7. That is 1 minus 7 by 10 is 3 by 10. Now, look at the part as to why I'm doing this sum. I am asking you probability A complement given C complement. Understand? Probability A will not take place given that C has not taken place. As per the formula, do not by heart. Again, I'm saying, what is A given B? A and B upon B. So, A complement given C complement is probability A complement intersection C complement upon C complement. Can I say A complement intersection C complement is 3 by 10? So I'm writing this value over here as 3 by 10, and C complement is 1 minus probability C. You know probability of C is half. So will I have this over here as 3 by 10 upon 1 minus half is divide by half, which is into 2, and hence my answer over here is 3 by 5. The only reason, students, for putting up this sum is to touch base the third part. If my question is directly asking you the third part, note you will have to find the second part, that is A complement intersection C complement. So try to understand and match the pattern. Let us go to the next sum, which says word problem, again on the same concept. My only request here is do not jump to direct answers. Read, get it in a symbol form, then go for interpretation. So in a college, 70% students passed in physics, 75% pass in maths. Now, 10% students fail in both. My question says one student is selected at random. What is the probability that the student will pass in physics and maths? Okay. Pass in maths given that he passed in physics. Okay. Pass in physics given that he passed in maths. Look at the interest area. You are interested that the student should pass. Okay. So therefore my 10% students fail in both is an important concept. How do you define the event? I am defining P as an event that student will pass in physics. M as an event that student will pass in mathematics. Okay. My question says 70% of the students pass in physics. 75% of the students pass in mathematics. But it says 10% student fail in both. Do not jump to answer. Fail in both meaning fail in both means the student failed in physics and he failed in maths. Get the symbol right, you will never go wrong. This actually is probability P union M complement, which is given to you as 10%. So again with De Morgan's law, do I know P union M will be 90%? What is union? Pass in physics or maths or both. So the missing data here was intersection. Why do I need it? I need it for conditional probability. So can I use this formula over here and say probability P union M is probability P plus probability M minus probability P intersection M. So even if you can cancel the answer, wait. If the denominator is common, it is easier for you to solve the answer. So this is 90 by 100. For physics, 70 by 100. For maths, 75 by 100. And this value, I don't know. If I bring the value on the left hand side, will this be 70 plus 75 minus 90 upon 100? 70 and 75 is 145 minus 90 is 55 by 100. Now bring this to least fraction, which over here will be 11 by 20, or you may write it as 0.55. Get the last answer in least fraction or the decimal value. So my first part of the answer is done. Second part of my question says the student will pass in maths given that he has already passed in physics. So probability pass in maths given that the student has passed in physics, that is M intersection P upon P, which you already found as 55 by 100. Physics is 70 by 100. Left over here with 55 by 70, again least fraction, that is 11 by 14. Means what? For every 14 students who pass physics, 11 will pass maths. Okay, what if I ask you odds in favor? Do we know odds in favor is favorable is to unfavorable? Then this answer will be 11 is to 3. Just note one statement how it can tweak up your answer. Next one, the student will pass in physics given that he is passed in maths. Pass in physics given that he is passed in maths is P intersection M upon M, which I know P intersection M again is 55 by 100 upon 75 by 100, which is 55 upon 75 is 11 by 15. For every 15 student passing in maths, 11 will pass in physics. Please understand, a common based similar question was asked in 2014 ISC paper. Let's look at the next part. My question says, assume that each child born is equally likely to be a boy or a girl. If a family has two children, then what is the conditional probability both are girls given that a condition has happened. Understand? I am saying assume that each child born is equally likely to be a boy or girl. And if there are two kids in a family, can my sample space be boy, 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 girl, girl, boy, girl, girl? This is my sample space. My question says probability. What is the conditional probability? Both are girl given that youngest child is girl. So probability both girl given youngest child is a girl. I'm assuming the first written name is the eldest child and then the youngest child. So probability both are girl given youngest child is girl. Youngest child means the second child is girl, which happens where? Which happens here and here only. I do not have to look at the four parts. I only have to look at the part where the youngest child is girl. That is happening in 2 out of 4 cases. And in this, I am saying both are girls is 1 out of 4 cases. And hence my answer is 1 by 2. So if the youngest child is girl, probability that both are girls is 50% chance. Second part says, what is the conditional probability? Both are girls given that at least one girl. Now I am saying probability both girls given that at least one girl. Now, at least one girl means one or more, which will be where one girl, more than one girl. So, given at least one girl is 3 by 4. Both are girl child is only this, which is 1 by 4, and answer is 1 by 3. A very good question where if you do not look into the filtered conditional part, there is a high tendency of you going wrong. The same thing can be tweaked up when I say by tossing a coin head and tail. So please be very mindful when you read this sum. Let's look at the next question, students. My question says a committee of 4 is selected at random from 8 boys and 4 girls. There are 8 boys and there are 4 girls. You are selecting a committee of 4. I'm not reading further. What can happen? Committee of 4 means it can be 0 boys and 4 girls, or 1 boy, 3 girls, 2 boys, 2 girls, 3 boys, 1 girl, 4 boys, and 0 girl. Very careful. I'm re-saying, I'm reiterating the part. 0 boys and 4 girls, or 1 boy and 3 girls, or 2 boys and 2 girls, or 3 boys and 1 girl, or 4 boys and 0 girl. Why am I taking a pause here? Whenever I say or, I will add. Whenever I say and, I will multiply. So if you get the grammar correct, your sum will not go wrong. Now, these are all possibilities. How we listed it here. What does my question say? Given that there is at least one girl in the committee, calculate the probability there are exactly 2 girls. Given that at least one girl, that means this has already happened. Given that at least one girl means I'm only going to consider this part. Given that this has already happened, what is the probability there are exactly 2 girls in the committee? So my answer is probability exactly 2 girls given at least one girl. So exactly 2 is this case. That means out of 8 select 2 and out of 4 select 2 upon this entire part. That means out of 8 select 0, 4 select 4, 8 select 1, 4 select 3, 8 select 2, 4 select 2 and 8 select 3, 4 select 1. You can put this value in a calculator carefully and get the final answer. A very important sum as to how do you solve it further. Let's look into the last sum for today. My question says an instructor has a question bank consisting of certain options. Now, the sum is not difficult, but it is lengthy to confuse you. What do you have? An instructor has a question bank consisting of 300 easy true or false question, 200 difficult true or false question, then 500 easy MCQ and 400 difficult MCQ. This is how your paper consists of. My question says if a question is selected at random from the question bank, then what is the probability that it will be easy question given that it is a multiple choice? Okay, now understand. Total how many questions are there? If you look over here carefully, I have total 1400 questions from which you're selecting one. So for the first sum, I'm going basic. Then we'll try to jump the step. My question says, what is the probability it will be easy question given that it is a multiple choice? Probability easy question given it was a multiple choice question. Now, how many easy questions are there? You have 300 easy questions, you have 500 easy questions. But my question says you only have to look into the multiple choice. Okay, so limit yourself when you're looking to multiple choice. Multiple choice, how many questions? 900. Out of which easy are how many? 500. So your answer is 500 out of the 900, that is 5 upon 9. Next part, true or false given it is difficult. Probability true false given it is difficult. I only have to look at difficult question. How many difficult questions are there? Difficult questions are 200 and 400. In this, how many belong to true and false? Only 200. So my answer over here is 200 upon 600, which is 1 upon 3. Last part, difficult question given it was MCQ. Difficult question given it was MCQ. Pause. How many MCQs are there? This part, MCQs are 500 and 400. In that, how many are the difficult ones? 400. So my answer over here is 400 by 900, that is 4 by 9. So today students, we have done sums based on conditional probability, that an event will happen given that something has already happened. You will get a difficult question given that it was an MCQ question. So the important crux out here is that you understand the word problem. First, break it into simple known language, then jump to your answer. In the next session, we will be exploring sums based on law of total probability along with Bayes' theorem, which we will also solve in the form of a tree diagram. So if you like this session, kindly share it with your friends and subscribe to the page. That gives us a good motivation to put up more sums of this type. Thank you and happy learning.